Hi, Trig. We are firmly in chapter 5. Right now we're in 5-3, and I only showed you the first part of solving trig equations and what a general solution was and how to work with them. Okay, before we get into the second part of 5-3, I wanted to do a little prerequisite skill, and it's this thing, quadratics, solving quadratics. So way back when, get in your time machine and go back to your Algebra 1 or Algebra 2 days, we needed to solve quadratics. We need to figure out when this will be equal to 0. What values of x would I plug in and get 0? Okay, to do that, we needed to factor. Okay, really this came from two factors being multiplied together and getting 0. And then we can set each one of these equal to 0 and solve it. But the tricky part is, do you remember how to factor something like this? It was on your algebra review, so hopefully you kind of shook the rust off a little bit. If not, here's a little tip on how to do it. How I teach this is called using the x method. We use the x method to factor quadratics. We start by drawing an x, and we draw two little fraction bars. Okay? In the top of the fraction bars goes whatever the quadratic term is, minus the squared. So we're just going to do a 3x and a 3x. Easy enough. Then we put the middle number, the linear coefficient is what that is, here in the bottom. And then we multiply the constant and the leading coefficient. So we're going to multiply the first and the last one. That goes on top. And the middle one goes on bottom. This is the setup for the x method. It's a lot of steps to set up, but it's neat and orderly, and I like it. From here, where we're playing that game, you played a lot of this game in Algebra 2. What two numbers multiply to negative 15 and at the exact same time add to a positive 14? Okay, well, if we think about it for a while, hopefully you would come up with 15 and 1. Those things will multiply to 15 and add to 14 as long as the 1 is negative. Now, in this case, 15 times negative 1, negative 15. 15 plus negative 1, 14. Good. From here, to finish this up, we are going to simplify this fraction. I will just divide by 3, and get x and a positive 5. X and a positive 5. This one, I can't simplify this anymore, so that's what it is. It's 3x minus 1. That's the factoring part. Now for the solving part, the ZPP, the zero product property, says if I multiply these two things together and get 0, one of them, at least one of them, is equal to 0. So I'm going to set that one equal to 0 and get negative 5. And then I'll set this one equal to 0, add 1, and then divide by 3. So I'll get negative 5 and positive 1/3. Those are my roots. Those are my zeros. Those are my solutions. If you plug those numbers in here at the very beginning, negative 5 and a negative 5, you would get 0. Or if you plugged in 1/3 and 1/3 and ripped it through, you would get 0. Those are my solutions. Prerequisite skill. You gotta be able to do that. And not only do you gotta be able to do that, but it's going to be involving trig. There's going to be sine and cosine and tangent. So this is a skill that we're going to see today. Okay? So without further ado, let's go ahead and do the notes for today. 5-3-2. We're continuing to solve trig equations, only some tougher things happen. Some more things happen. Some little wrinkles are thrown at us, and we just have to be prepared for them. So I think I just do 3 or 4 example problems, and that's it. I mean, it's not really about teaching you something new. It's about just fine-tuning what we already know. Okay? So here's our first one. If you want to hit pause and give it a try and see what you can come up with on your own, that's the best course of action. When you come back, we'll see how to do this for real. Okay, we're back. Sometimes it's helpful to strip away all the trig stuff and say, well, what if these were just variables? What if my cotangent x was just an x? And what if my cosine x was just a y? That would be y squared. What would I do with this thing? And if you said, hopefully you said, subtract the 2x over to the other side. What's going to be common here? What students see here in the pink and up here in the maroon is, oh, I have a cotangent on both sides. I want to divide a cotangent. I'll divide both sides by cotangent and be left with this. You are not allowed to do that when you're solving equations, because you could actually eliminate one of the answers. Okay, when you divide and cancel, you're actually canceling out solutions to the problem. So we cannot divide things off. We don't want to cancel things off when we're solving trig equations like this. Variables. Okay, numbers are okay. If we had a times 2 on this side and a times 2 on this side, sure, divide both sides by 2. But we don't want to cancel off a cotangent x and a cotangent x, a variable, because then we're getting rid of answers. So what we're going to do instead is get everything on the same side and factor. Same thing we were just talking about before, that factoring thing. Okay, so I'm going to subtract this 2 cotangent x, easy for me to say, over to the other side. Now I'm going to do some like terms. Okay, this one does have a cotangent x. This one does have a cotangent x, so I'm going to factor that to the outside of some parentheses. Okay, and now the zero product property. If I'm multiplying this times this and get 0, well, I'm just going to set each of them equal to 0. I'll set cotangent equal to 0, and I'll set cosine squared x minus 2 equals 0, and solve them. So let's go through. There's the first one. Cotangent x equals 0. Okay, so we're not talking triangles. I can't draw a triangle and get these values as 0. So I need to do those other definitions we had. Cotangent is the x-coordinate over the y-coordinate. I want to know when is the x-coordinate over the y-coordinate equal to 0, right? Equal to 0 over here. Well, if it's a fraction, for a fraction to be 0, the x-coordinate, the numerator in this case, the numerator has to be 0. So I'm really looking to see when is x equal to 0. Because when x is equal to 0, this whole fraction is equal to 0. And that's what we're looking for here. So when on the unit circle is x equal to 0? When is the x-coordinate equal to 0? Okay, right here, the x-coordinate 0 at pi over 2. And down here at 3 pi over 2. So then we would just need a general solution. We want this one, and then this one, and then this one, and then this one, so on and so forth. That'll give us one of our sets of answers, all the answers for this one. Now let's try this one. I'm going to set cosine squared x minus 2 equal to 0 and solve it. Oh, well, there's the general solution I was just talking about. I should have been looking ahead, huh? Pi over 2, 3 pi over 2, 5 pi over 2. We're just going to start with the first one, pi over 2, and then add half a circle each time. Half a circle is pi radians, so add pi, add pi, add pi. There's my general solution for just that part. Now let's go to the other part. Cosine squared x minus 2. Okay. Cosine squared x minus 2 equals 0. I will add 2 to the other side. I will take a square root. Not forgetting the plus or minus square root of 2. Square root of 2's look pretty familiar for us, but thank you, bell work. If you did the bell work ahead of time like you were supposed to, the cosine is never equal to that. Cosine of x square root of 2 would be square root of 2 over 1. And you might want to be tempted to say, okay, well, cosine is adjacent over hypotenuse, or adjacent over hypotenuse. It is. There is no triangle we do. This is impossible. This is bad. This has a hypotenuse of 1, and it has an adjacent side of 1.4. That you can't draw a triangle like that. The hypotenuse has to be the longest side. This gives us no solution. This is impossible. Cosine of x. Think about cosine, like the graph of cosine. The graph of cosine just bounces back and forth between 1 and negative 1, 1 and negative 1. It's never 1.412. Never happens. Impossible. No solution. Thank you, bell work. Okay? So the only answer to the original equation is pi over 2 plus pi n. That's our general solution that will solve this equation. Okay? Let's try another one. Here's a new wrinkle for us. The new wrinkle is solve this equation on the interval 0 to 2 pi. What that means, 0 radians to 2 pi radians, that's just one time around the circle. I don't want a general solution anymore. General solution has me going around the circle over and over and over and over, getting all those coterminal angles. When we see this little direction tacked onto our problem on the interval 0 to 2 pi, that just means one time around the circle. When will this happen? Just list the answers one time around the circle. I didn't like the way I wrote this. It was supposed to be a bracket, so I wrote it neater here. I didn't want to redo the whole note. That means that since 0 and 2 pi are basically the same thing, we don't want to list both of them. So if that happens to be one of our solutions, we'll include the 0. That's what the bracket means. Don't put 2 pi. Okay? So here we go. 2 sine squared x minus sine x minus 1. Again, if it looks foreign to you, like I don't know what to do with this, I mean, I could try changing that to cosines. We have all those formulas. If it's not abundantly clear, sometimes it's helpful to write it in algebra land. Okay, what if it looked like this? What if it wasn't sine? Oh, okay, it looks like a quadratic to me. I would have to factor the quadratic using the x method. Ooh, there's a reason we did that. Okay, so let's look at the x method for this one real quick. 2x squared, so a 2x and a 2x go on top. I multiply the first and the last one. That goes on top. The middle one goes on bottom. Okay, now we want two numbers that multiply to the top and add to the bottom. Multiply to 2. Well, the only things I know that multiply to 2 are 2 and 1. They have to multiply to a negative 2. That tells me one of these has to be negative. And they need to add to -1. That tells me this one has to be negative. Now these two numbers multiply to -2, and they add to -1. Perfect. From here, we simplify the fraction, and I would get x minus 1. This I can't simplify, 2x plus 1, and we're dancing. So we factored it. There it is, 2x plus 1 and x minus 1. But this was just our algebra version, right? We're not really in x's, we're in sine x's. So really, after we factor this part in black up here, it would factor to this. Now we do the ZPP. We set this one equal to 0, and we set this one equal to 0, and then get all of our answers. So let's go ahead and do that. Or you could hit pause and do it yourself. You should be hitting pause all the time. You guys should be trying these. I'm not going to give you time all the time. You hit pause. Go at your own rate, please. Okay. So we're here. I'm setting these two equal to 0 and solving them. Okay, that's not too bad. Subtract 1, divide by 2, add 1. This one's asking, when is sine negative? Well, sine is negative down here in the third quadrant and the fourth quadrant. Sine is opposite over hypotenuse, so I'm labeling the sides of my triangles. And remember, we're trying to find the angles. One time around the circle. I don't need the coterminal thing. I want to know what this angle is and what this angle is. Okay, well, my reference angle, if this is a 1, this would be 30 degrees, or pi over 6 radians. So from here to here, 6 pi over 6, one more, 7 pi over 6. Okay, from here all the way around, that would be 12 pi over 6. Back it up one, that would be 11 pi over 6. Those are my two answers for this one. Over here now, I can't draw a triangle for this one. Sine is equal to 1. I mean, you could write it as 1 over 1. But then you have the opposite side being exactly the same as the hypotenuse. You can't draw triangles for this, so we need those other definitions. When is sine equal to 1? Well, those other definitions, sine is the y-coordinate. When is the y-coordinate equal to 1 on the unit circle? At pi over 2. There's our answers. Just these. No general solution. You don't need to add 2 pi in, okay? One time around the circle, on the interval 0 to 2 pi, your answers would be 7 pi over 6, 11 pi over 6, and pi over 2. Okay, that's two of our examples. I'm going to end the video there so I don't run out of time on the next two. We'll go through those examples, and then you're equipped. You're hanging in there, okay? Keep fighting. Moving on.